Alright, so with when you are solving, you can use these steps. I like to label my sides. If you're somebody that learns best with visuals, I do think that this is helpful. So when you label your sides, you're going to label them the opposite side, the adjacent side, and the hypotenuse. Once you have those labeled, you can see what you're missing, what you need to solve for, and what you have, so that you can set up an equation using the corresponding trig function. Okay, so yesterday we were finding all 6 trig functions. Okay, today we are going to choose the one that fits the situation. Okay, and this is equation. Okay, if you want to write out equation, you can do that. Okay, and then the last step is going to be to solve for your unknown. Okay, so it's solving for the variable. Okay, so whatever your unknown is, that is what you are going to solve for. Okay, so for example 1, it says use a trig function to find the value of x, and I'm going to give you what the values are, what your triangles are. Okay, so I'm going to be working with triangles today. Your triangles do not have to be perfect, but I want to really good cool things. Okay, so I just want you to draw a right triangle. Okay, this is labeled as 30 degrees. Okay, and then this is labeled as x. This is labeled as 74. Okay, so I want you to draw that picture, and I want you to do step 1. So I want you to label the O, the H, and the A. Okay, so I just want you to label the O, the H, and the A. Alright, so the angle that's labeled is the 30 degrees, and so we can label from that angle. Technically, you could solve for the other angle and use that as well. Okay, but if we're going from the 30 degrees, the opposite is across. Hypotenuse is always across from that right angle. Okay, so, and then this would be the adjacent side. So your unknown is the O. Okay, the known side is the 74. So if you have O and H, are we going to use sine, cosine, or tangent? The sine. Okay, so we're going to use the sine of theta equals O over H, since that's what we're given. Okay, and remember, this theta symbol, that just means that's your angle. Okay, that's your symbol for the angle. So we're going to be plugging that in today. So from our angle, 30 degrees, we have the sine of 30 degrees equals x over 74. Okay, this is something that you did in geometry. You had to solve for x. Do we remember how to solve an equation like that? Yep, just multiply both sides by 74. Okay, and then we are going to use our calculators to calculate 74 times the sine of 30. Okay, so x is equal to 74 times the sine of 30 degrees. With your calculator, most of you are probably in radians, because every time we set our calculator reset it, it goes back to radians. So if you have a calculator like mine, it tells you here if it's radians or degrees. So because we're inputting degrees, we need to be in degree mode. So we're going to go to mode. If you go down here, you can see it's blinking on the radian. Go ahead and select degree. I'm going to write a little note here as your reminder when you're doing this that you have to be in degree mode. Okay, and then we can just type in 74 times the sine of 30. Based on our solution, can you guys tell me what the sine of 30 is equal to? It is equal to 1/2. Okay, so you should get x equals 37. If you're not, then check your mode, make sure you're in degree, okay? Do you guys remember anything special about a triangle that has a 30-degree and then a 60-degree angle? Yeah, we have some different formulas. Do you guys remember the other special triangle type? 45. Yeah. Okay, so we're working with those next week. Alright, so the next right triangle. Okay, this is labeled as the 45 degrees. Okay, so for this one, I want you to set up your equation and see if you can solve this one. Now, when you have to round, we are going to round to the nearest tenth. Oh, and I apologize. We also need this x and then 1. Okay, so go ahead and label your sides. And then from here, let's see if we can set up the equation and solve. Okay, now, if you are using this angle here, then you have the adjacent side and the hypotenuse. So you should be using cosine. So the cosine of 45 degrees is equal to x over 20. Anytime this is in the denominator, you're going to multiply. So you can either show that you're multiplying each side by 20, or if you want to just do 20 times the cosine of 45, that is fine. Okay, so if you do 20 cosine of 45, and you round this, you're going to get 14.1. Now, if you accidentally did the sign for this one, you may notice something interesting. If you do the sign with this, you get the same thing. That's because this angle is also 45. Okay, so that would only happen in a 45, 45, 90. Alright, and then we're going to do one more time. Okay, so we're going to draw a right triangle. We're going to label this as 20 degrees. This side as 6 degrees. And we want to find the base of that triangle. Okay, so let's see if we can do that one. And once you completed it, because I think some people are are working pretty quickly. Feel free to read through the next story problem. Okay, so Ryan, for this one, did you use sine, cosine, or tangent? Yes. Okay, so you have the opposite and the adjacent. All right, and then Penny, can you tell me what your equation would be for this?
Tan 20 equals 6 over x.
Great, tangent of 20 equals 6 over x. So for this one, notice that the variable's in the denominator. You do not want to multiply by 6. Multiplying by 6 would make this 36 over x, right? So instead, what can we do? Yeah, you can multiply both sides by x. Did any of you set up a proportion? You do that as well. Okay, so if you multiply both sides by x, and you want to get x by itself, then you're going to have to do what to both sides? Yep, then you're going to divide both sides. I'm going to write it as this. Okay, but you can also think of this as a proportion. If you put this over 1, 6 times 1 equals x times the tangent of 20. Divide both sides by the tangent of 20. So this is what you're plugging into your calculator. Okay, 6 divided by the tangent of 20. Okay, and then we're going to round to the nearest 10. Okay, so Ian, what did you get for that?
16.5.
Yes, so when you round, you are going to round up to 16.5. Okay, how many of you remember that from geometry? Thumbs up if you remember that well. Okay, now we're going to do some story problems. Do you guys remember, did you do story problems in geometry with your Coca-Cola? Okay, so in a water skiing competition, a jump ramp is 19 feet long from the water to the top of the ramp. If the angle between the ramp and the water is 15.1 degrees, what is the height to the nearest foot above the water that a skier leaves the ramp? So at the very least with your story problems, I want you to draw a picture. And that picture just has to be a triangle. Okay, so we're working with right triangles here, so I'm gonna draw mine. If you would like to add more detail, you can. But when you're trying to figure out how this story problem relates to the triangle, I try to pick out some keywords. So it's a right triangle. When it's asking me what is the height, is there anything you guys remember about how to identify the height from geometry? Is what? Oh, a lot of times you use the tangent. This depends on what you're given. So sometimes you use tangent, but how do you know which side it's going to be for the height? Yeah, it always has to be with the right angle. Okay, so if I'm trying to find the height, I'm trying to find this side, so I like to call that x. Okay, so a jump ramp is 19 foot long. So if a person in water skiing, my ramp's in the water. This is a very steep and large ramp, okay? If I have a water skier that's going up the ramp, which side are they going up? The hypotenuse or the base? The hypotenuse, right? They're not going to go here. That's the bottom of it. Okay, so if the jump ramp is 19 feet long from the water to the top, then I can label this as my 19 feet. Okay, and then it says the angle between the ramp and the water is 15.1 degrees. So now I can label my sides according to this angle. So from 15.1, I have the opposite side and I have the hypotenuse, which means I'm going to be using which trig function? So H would be sine. Yep, so it's the sine of the angle equals the opposite over the hypotenuse. Okay, and like we've seen, if it's on the bottom, you are just going to multiply those together. Now this is to round to the nearest foot. So the nearest foot is going to be the nearest whole number. Okay, so go ahead and calculate that. And then here, once you have that calculated, just let me know what you get. 5 feet is correct. Okay, so whenever you're rounding to the whole number, you're looking here. That's going to tell you whether it rounds up or stays the same. All right, in example 3, there's a biologist whose eye level is 6 feet above the ground, and it says that they measure the angle of elevation to the top of a tree to be 38.7 degrees. The biologist is standing 180 feet from the tree's base, and what we need to do is find the height of the tree to the nearest foot. Okay, so again, we're rounding to the nearest whole number. So I showed you this on our opening slide today, but let's just do like a little information box. Okay, so let's remember what the angle of elevation and the angle of depression is. So you always have to start with a horizontal. Horizontal line is straight across. Okay, if you have an angle of elevation, just like, well, just like an elevator, and an elevator does go up and down. Okay, but when you elevate something, you are going up. So from the horizontal, if you are going up, that is the angle of elevation. Okay, and if you think about depression, right, I usually think about, oh, I'm feeling down, right? So if it's depression, you're going down from the horizontal. Okay, so the angle of elevation starts from the horizontal, goes up. Depression starts from the horizontal and goes down. Okay, so those are two things you will see in your assignment. Okay, so the biologist has the eye level of 6 feet above the ground, and that angle of elevation is 38.7 degrees. They also say the biologist is standing 180 feet from the base. So whenever I do a story problem, I start with a triangle, and it doesn't matter which way you make it. Okay. But I always start with my right triangle because all of our problems here are going to be right triangle problems. So anytime you have a story problem, I would like a picture to accompany that. Okay, and then we're going to draw the biologist in their eye level. So here's their eyes. My biologist. Okay, now the eye level is 6 feet above the ground. So I know from the eye level to the ground is 6 feet. Is my name on my biologist? All right, and then where is he looking to? then top of the tree. So let's put our tree in here. The top of it. Put our tree. Alright, so beautiful. And then what we are trying to find is the height of the tree. So we are trying to find from here to here. Okay, so I have in the 6 feet angled elevation to the top of a tree. So elevation starts from the horizontal, which is here. Okay, so I'm going to label this as 38.7 degrees. Okay, and then am I missing anything? Missing any information that I need to add in? Okay, so the 180 feet, can you get label where that should be on your diagram? So if it's 180 feet from the base, which part of my triangle should I label? What side's going to be the 180 feet? The base, the bottom here, right? 180 feet. Alright, so if I'm going to find the height of the tree, what am I going to have to do? I'm going to have to find something in my triangle. What are we trying to find? Which one's that? So what? Well, the height of the tree? Yeah, you can think of the height of the tree as x plus 6, right? So first I just need to find this side of the triangle. I would call this x. You can call it another variable if you call this x. But really, when you're finding the height, you're going to have to take x and do what with it? Yeah, you're going to have to add 6. Okay, so this is going to be 2 parts. So the first thing we're going to do is use one of our trig functions. Okay, so if I label from this angle, this is the opposite side. This is my adjacent side. So O and A means I'm going to use which trig function? Tangent. Okay, I really feel, and I think you guys will agree, the hardest part of something like this is setting it up. Once you set it up, we're pretty good at the calculation. Okay, so we're going to solve for x. If x is on the top, oops, I put 180 degrees, sorry, not degrees. I guess it used to write the degrees of that. Okay, and again, you can round this to the nearest foot. Okay, and then, again, once you've calculated that, let me know what you did. Well, what'd you get for the first one? 144. Okay, good. So we'll round that to 144, at 144.2. Okay, so that means this is going to stay. Okay, and then your final answer is going to be 150. Alright, any questions for me on page 1? So page 1 is all based on Silvertello. I guess that is a lot of review from geometry. Okay, you might also remember a little bit of that from geometry. This tends to be something people need some reminders on, and we're going to be working with radians. So this key concept that we're going to talk about on the back is the arc length. So if you have a circle with a radius of r and a central angle in radians, then the arc length s equals the product of r and theta. So the way that we write that is s equals r times theta. Now, remember, the central angle is in radians, okay, so not in degrees. And and then you have your radius of r. Okay, so the radius always goes from the center to the edge of your circle. That is your r value. Your theta, I don't know if do you guys remember how the central angles work? It's just whatever your angle is here, that is your central angle. That's your theta. Okay. And then what you are finding, okay, the arc length is this. Okay, that is your S. I guess I should have put it in purple. Okay, so that is your value of S. So in example 3, we're going to find the length of the arc. We're going to round to the nearest 10. Okay, and then there are other times where you're going to have to write that as an exact value, so we're going to practice that as well. So based on my picture, it labels the radius is 3 feet. Okay, and my theta is 4 pi over 3. Okay, so S is going to be 3 times 4 pi over 3. Okay, and if they ask you for an exact value, that would just be 4 pi, and that is going to be feet. And then when you round to the nearest tenth, we're going to use the pi button. Okay, so it's going to be 4, and then your pi button is right here above the little caret button. Okay, and that is approximately 12.6 feet. Okay, so if they ask you for an exact value, you're going to have pi in it. If they ask you for the rounded value, 12.6. Okay, and then we are going to include our units for our story problems. Okay, now we're going to apply this to some story problems. So if a surveyor's wheel with a diameter of 30 inches, diameter of 30 inches. Do you guys know what a surveyor is?
Well,
sometimes you will see them like out on the road. Okay, so it's like a big wheel and then they're measuring stuff. So the diameter of 30 inches completes 13/20ths of a rotation. Okay, and then what we have to find is what is the total distance traveled in feet. And we are going to round to the nearest hundredth if necessary. Alright, so the first thing we want to do is think about how you can get the radius if you know the diameter. So do we remember the relationship between those two? Yeah, so it's half of it. Yeah, so you can divide by 2. You can multiply by a half. Okay, so if you know the diameter is 30 inches, that means the radius is going to be what? 15. Okay, now we are going to be using the same equation where the arc length is the radius times theta. And when you have one full rotation of a circle in radians, what's one full time around the circle in radians? In degrees, it's 360. Yep, it's too high. Okay, so in order for us to find theta, we have to find 13/20ths of 2 pi. Yeah, so we just multiply together. Okay, so it'll be 13/20ths times 2 pi. Okay, we're going to write this as an exact value first. Okay, so 2 over 20 reduces, or you can just think of it as over 1. So 26 pi over 20, what does that reduce to? 13 pi over 3. Okay, so in order to find out what your theta value is, if you know 1 whole time is 2 pi, you can just multiply it by your rotation amount, and that's going to give you your value for theta. So now we're ready to use our equation, S equals R times theta. Okay, so again, you are going to have to find values as the exact value. Okay, and then when you're doing this, I would just simplify it. So 5 and 10, sorry, 15 and 10, what goes into both? 5. Okay, so divide by 5, divide by 5. Okay, so then you would get 39 pi over 2. Okay, and then remember, this radius is in inches, so what you have here, this is in inches. If we look back at the direction, it says what is the total distance in feet? So I'm going to have to convert. Okay, so because the radius here is in inches, this solution is in inches. It asks for it in feet, so I'm going to have to convert. So if you have 39 pi over 2 inches, remember how we can set up our conversion. So we want inches to be in the denominator so that they cancel. What is the ratio of feet to inches? 1 to 12. 1 foot is 12 inches. Alright, and then we can calculate this. So we're going to have 39 pi over 24. And let's see what we get. 39 pi divided by 24. And it says round to the nearest hundred. So that would be 5.11. Okay, so we are going to have to pay attention to our units here and what our question is asking us. Alright, our next word problem has to do with a merry-go-round at the playground. And they tell you that the radius is 6 feet. Okay, Romeo stands on the edge and his sister pushes him around. How far does Romeo travel if he moves through an angle of 5 pi over 4 radians? Okay, and we're going to round that to the nearest 10. Okay, notice it's asking you how far. Whenever they're asking you how far, what you are trying to find is that arc length S. Okay, and it does say that we're going to be rounding to the nearest 10. Okay, so for part A, we're going to use S equals R times theta. We're given the radius. We are given the theta. We just have to compute. Okay, so you can do 6 times pi over 4 in your calculator. You can also do 30 pi over 4. You can reduce that if you want. Okay, because it tells us to round to the nearest tenth, I'm just going to do 30 pi divided by 4 here. Okay, so 23 point, if it's 5, 6, that's going to round up to 0.6. And remember, whatever they give you for the radius, that is going to be your unit. So 23.6 feet. Okay, now for part B, it's asking you through what angle does Romeo move. So when they're asking you through what angle, you're trying to find what variable? Theta. You have to find theta. And then he travels a distance of 80 feet around the circumference. Okay, and this one says write your answer as an exact value. Alright, so we're still going to be using x equals r times theta, but this time we're going to solve for theta. Okay, the radius is still 6 feet. Okay, and then we have to find, it says the distance of 80 feet around the circumference. So this 80 feet, we're going to plug in for s. Okay, the distance is going to be the arc length. They tell you around the circumference because remember, the circumference is just the edge of the circle. So if you travel 80 feet, that's your value of s. Okay, and then when you solve, we'll just need to divide both sides by 6 and then reduce. So we're leaving this as an exact answer. We know that 2 goes into both, 3 does not go into 40. So your solution is going to be 40 over 3 radians. So remember from the other day, I said most of the time radians has pi with it, but that's not always the case. You can have 40 over 3 radians. Okay, that is your value for theta. Okay. The last application for the arc length is going to have to deal with a clock, okay, that has the hour hand and the minute hand. Okay, so with your clock, let's first draw a picture of one. Okay, and the clock always starts with what? Value. Well, okay. So we have to find the radian measure of the angle through which the hour hand on a clock rotates from 4 a.m. to 6 p.m. Okay, so I like to have the visual. Especially as our digital clocks become more prevalent. Okay, so if you are at 4 a.m. and you need to go to 6 p.m., the hour hand is definitely going to travel one full rotation, right? Okay, from 4 a.m. to 6 p.m. Okay, so if you have one full rotation, it goes from 4 a.m. to your 4 p.m., then we're going to be adding something else to it. So one full rotation is equivalent to 2 pi. We have to find how much we have to add to it. Okay, so from 4 p.m. to 6 p.m., we have to find this distance. You know what it is?
Yeah.
So we're gonna do it in radians, but yeah, you can think of it as a ratio. So how many spaces do we have here? 12. You guys with me on that? And then from 4 to 6, that's how many of those spaces? Yeah, so it's going to be 2 pi over 12. Okay, so when you have that full rotation of 2 pi and you divide it by 12, each little space is pi over 6, which is how many degrees? 30 degrees, okay? So if you had 2 of them, I heard somebody say 60 degrees earlier, it is equivalent to 60 degrees, and then you just have to write that in radians. So pi over 6 is the distance between each number on the clock. Okay, because the whole thing is 2 pi. I have 12 spaces. Okay, each one is pi over 6. Okay, so you can just multiply pi over 6 by 2 because it's 2 spaces from 4 to 6. And then we just add that to 2 pi. Okay, so once you do that calculation, 2 pi over 6 reduces to what? Pi over 3. 2 6 is 1/3. So if we're going to add those together, we did this in one of our earlier sections. We got a common denominator. And then when we add 6 pi plus pi, we get 7 pi over 3. Okay, 7 pi over 3 is not your final answer, but it's very close. Okay, so when you are working with a clock, you are going clockwise. Remember from our first day, if you're going clockwise, what type of angle is that? It's a negative angle. So it's a negative rotation. Okay, so your value is going to be negative 7 pi over 3. Okay, so anytime you are doing a clockwise rotation and you are trying to find theta, that is going to be a negative value. Okay, and then your homework tonight is your worksheet. Okay, those are being packed down now. Okay, am I in the same? Yeah.